There's somewhere between 200 billion and 2 trillion galaxies in the observable universe, each one packed with billions, sometimes trillions of stars. That means the total number of stars out there isn't just big. It's a number so large your brain can't actually picture it. More stars than every grain of sand on every beach on Earth. So here's a question that sounds stupid, but isn't. If there's that much light in the universe, why is the sky black at night? Not, why does it look dark to us? Why I ask it dark? Because if you actually do the math, and scientists have, the night sky should not be black. It should be blazing, blinding white, every single second of every single night. This isn't a trick question. It's a real problem that confused some of the greatest minds in astronomy for over 200 years. It even has a name. And the answer to it accidentally proves one of the biggest facts we know about the universe, including how it began and how it's going to end. Stick with me. By the end of this video, you'll never look at the night sky the same way again. In 1823, a German astronomer named Heinrich Olbers wrote down a puzzle that had actually been bothering thinkers for centuries before him. Johannes Kepler mentioned a version of it back in 1610. And even earlier, in the 1700s, Edmund Halley, yes, that Halley of Halley's Comet, poked at the same problem. But Olbers is the one whose name stuck. Today, we call it Olbers Paradox. Here's the logic, and I want you to really sit with this, because it's simpler than it sounds. Imagine you're standing in the middle of an infinite forest. Trees in every direction, forever. No matter which direction you look, left, right, forward, backward. Eventually your line of sight is going to hit a tree trunk. It doesn't matter how far apart the trees are spaced. If the forest goes on forever, every possible line you draw from your eyes outward eventually smacks into wood. Now replace trees with stars, and forest with universe. If the universe is infinite, infinite in size, infinite in age, and stars are scattered through it fairly evenly, then every single line of sight from Earth, no matter where you point your eyes, should eventually hit the surface of a star. Not most lines. All of them, which means the entire sky, every square inch of it, should be just as bright as the surface of a star, as bright as our own Sunday. All the time, day and night. There would be no night at all, just one continuous blinding wall of light, 24/7, forever. Obviously, that's not what we see. We see a calm, dark sky with a few thousand pinpricks of light scattered around. So either the math is wrong, or something we're assuming about the universe is wrong. The math is fine. Our assumptions were the problem. And figuring out which assumption was broken is one of the coolest detective stories in the history of science. Before we get to the real answer, let's knock out the obvious guesses, because you're probably already thinking one of these, and I want to show you why they don't work. This is important, because it's exactly how real scientists tested this problem for 2 centuries. Good instinct. Totally wrong, though. Here's why. If the universe really is infinite in size and infinite in age, then light has literally had forever to travel. Given infinite time, even the dimmest, farthest star's light eventually arrives. Forever is a very, very long time. Distance alone doesn't solve the paradox. Also a great guess. Also wrong. Here's the catch. If a cloud of cosmic dust absorbed all that starlight over billions of years, the dust wouldn't just stay cold and dark. It would heat up and heat up and heat up some more until it reached the exact same temperature as the stars heating it and started glowing exactly as bright as they do. You can't hide infinite energy behind a curtain. The curtain catches fire. Wrong too, and this is a sneaky one. Even if stars are spaced enormously far apart, in a truly infinite universe, you still have infinite stars. Infinite anything, no matter how sparse, still fills every direction eventually. Sparse doesn't mean finite. So none of the common sense answers work, which means something deeper is going on. And this is where it gets genuinely mind-bending. Here's the first crack in the paradox, and it's the big one. The universe is not infinitely old. It's about 13.8 billion years old. That number is one of the most well-tested facts in all science. We've nailed it down using multiple independent methods that all agree with each other. Now here's why that number destroys Olbers Paradox. Light is incredibly fast, about 186,000 miles per second, roughly 300,000 kilometers per second. But it's not infinitely fast. It takes time to travel. And that means when you look at any star or galaxy, you're not seeing it as it is right now. You're seeing light that left it a long time ago. Look at the sun. You're seeing it as it was about 8 minutes ago. Look at the next nearest star, Proxima Centauri. You're seeing it as it was about 4 years ago. Look at a distant galaxy. You might be seeing light that left it millions, even billions of years ago. So here's the key idea. Since the universe is only 13.8 billion years old, there's a hard limit on how far away anything can be and still be visible to us. If a star or galaxy is more than about 13.8 billion light years away, its light simply hasn't had enough time to reach Earth yet. It's not that the light is blocked or absorbed or hidden. It's literally still on its way. It hasn't arrived. This boundary is called the observable universe, and it's genuinely one of the most important concepts in modern astronomy. We're not looking at the whole universe. We're looking at a sphere around Earth defined by exactly how far light has managed to travel since the beginning of time. Beyond that sphere, there could be more stars, more galaxies, maybe infinite more. But we cannot see them because their light hasn't gotten here yet, and by definition it never will, for reasons we'll get to in a second. This alone solves a huge chunk of the paradox. The universe isn't infinitely old, so there hasn't been infinite time for starlight to reach us and fill up the sky. But it's not the whole answer, because even within our observable universe, that 13.8 billion light year bubble, there's still an absolutely massive number of stars. Shouldn't that still be enough to light up the whole sky? This is where the second, even weirder piece comes in. In the 1920s, an astronomer named Edwin Hubble made an observation that changed everything. Galaxies aren't just sitting still out there, they're moving away from us. And the farther away a galaxy is, the faster it's moving away. This isn't galaxies flying through space like rockets. It's something stranger. Space itself is expanding, and it's carrying galaxies along with it, like raisins in a rising loaf of bread, getting pulled apart from each other as the dough expands. Here's why that matters for our black sky. When light travels through expanding space, the expansion stretches the light wave out along the way, kind of like stretching a slinky. This stretching is called redshift because stretching light shifts its wavelength toward the red end of the spectrum. For nearby stars, this effect is small. Their light stays visible light, just slightly redder than it started. But for extremely distant, extremely ancient light that's been traveling for 10, 12, 13 billion years, the stretching adds up so much that the light isn't visible light anymore by the time it reaches us. It's been stretched all the way out of the visible spectrum into infrared, and for the very oldest light of all the way into microwaves. That oldest light of all has an actual name, and you probably heard of it: the cosmic microwave background. It's the leftover light from just 380,000 years after the Big Bang, the earliest light in the entire universe. It's everywhere. It surrounds us in every direction, all the time. And here's the beautiful twist. That light is technically still here. It didn't disappear. It's just been stretched so far that our eyes, which only see a tiny sliver of the light spectrum, can't detect it anymore. We need radio telescopes to see it at all. So put both pieces together, and here's your full answer to why the night sky is black. The universe has a finite age, so there's a limit to how far light has had time to travel to reach us. Beyond that limit, there simply hasn't been enough time yet. And the ancient light that has reached us from the earliest, most distant stars and galaxies has been stretched by cosmic expansion completely out of the range our eyes can detect. The night sky isn't black because space is empty. It's black because we're looking at a young, growing, expanding universe, and our eyes can only see one narrow slice of everything that's actually out there. Here's the part that I think is genuinely one of the coolest ideas in all of science. Olbers Paradox isn't just a fun brain teaser. It's actual scientific evidence. Evidence you can gather with nothing more than your own two eyes on any clear night for free. Think about what it would mean if the sky wasn't black. If you looked up and saw a wall of blinding light in every direction, that would tell us the universe is infinite in age, static and unchanging, exactly what most scientists, including Einstein at one point, assumed for most of human history. But the sky is black, and that simple fact, dark patches between the stars, is proof that the universe had a beginning, proof that it's been expanding ever since, proof that we live in a universe with a history, not one that's just always existed exactly as it is now. Next time someone tells you there's no way to prove the Big Bang happened, you can tell them, just look up tonight. The darkness between the stars is the proof. It's been sitting there in plain sight the entire time, and it took humanity 2 centuries to actually understand what it meant. Let's lock this in with a fast recap. If the universe were infinite and eternal, the whole sky should glow as bright as the sunlight doesn't, because the universe is only 13.8 billion years old, so light from beyond that distance hasn't reached us yet, and light from the earliest galaxies has been stretched by the universe's expansion completely out of visible range into the cosmic microwave background. The black sky you see every night is direct, visible proof that the universe began and is still growing. So the next time you're outside on a clear night, take 30 seconds and actually look up. That darkness between the stars isn't nothing. It's the edge of what light has had time to reach you across 13.8 billion years of cosmic history. If this blew your mind a little, that's exactly the goal of this channel. Take one strange, simple-sounding question about space and dig until we hit the real, mind-bending answer. If you want more of these, subscribe. I've got the next one already lined up. Why do stars twinkle but planets never do? It's a 2-minute trick that lets you spot a planet with nothing but your naked eyes, and I'll show you exactly how in the next video. Drop a comment and tell me, what's a space question you've always wondered about but never actually got answered? I read every single one, and the best ones become the next video on this channel. See you in the next one.